This conference will now be
जैन
recorded.
हो गया इन्फॉर्मेटिका स्टार्ट हो गया क्लास इवनिंग है वो क्लास
हेलो सर।
जी हाँ बोलिए सुनने नहीं आ रही मेरी आवाज
ओ, हाँ आ रही हो सर। वो मेरा माइक है ना, वो अनम्यूट नहीं हो रहा था।
हाँ अच्छा मेरी
मोबाइल की
आवाज आ
गारंटी
रही
है ना। हाँ आवाज आ रही है सर।
ओके
सर वो टुडे 9:30 AM को ही हो स्टार्ट होने
एम पी
वाला।
एम
AM 9:30
मॉर्निंग
मॉर्निंग में।
अभी और एक 2 घंटे के बाद ज्वाइन हो जाएगा स्टार्ट हो जाएगा
हाँ हाँ, अभी 2 घंटे बाद।
9:30 टू 11:30
हाँ 9:30 to 11:30।
ओके वेरी गुड बेटा बहुत से
थैंक
जॉब्स
यू
है
सर।
देयर आर प्लेंटी ऑफ जॉब्स
हाँ ETL में ना,
हाँ
ETL में ना।
हाँ ईटीएल में ओरेकल में स्नोफ्लेक में टैबलो में yesterday we complete Armstrong number right yeah this is the logic what is the logic here okay अभी हो गया okay what is the logic behind this Armstrong number okay the sum of cubes of the individual digits should be equal to the same digit for example n is equal to 153 here s is nothing but sum starting sum is 0 starting sum is 0 while n greater than 0 while n greater than 0 what is n value 153 is it true yes रिकॉर्ड हो रहा है रिकॉर्डिंग आवाज सब आ रहे हैं राइट ओके it is true 153 greater than 0 next it will execute r is equal to this one r is equal to what is the n value 153 percentile 10 153 okay r is nothing but 153 percentile 10 percentile is nothing but it returns remainder okay percentile okay it returns remainder whereas slash returns coefficient got it if you use percentage this one it return remainder for example Scott Tiger invalid character but here it will return the percentile percentile means it return the remainder in C language okay in Oracle language we have mod function we have mod function 153 comma 10 in C language we have percentile here in Oracle we have mod function it returns remainder okay if you divide 153 by 10 what will be the remainder remainder is 3 what is the remainder remainder is 3 the last digit if you divide any number by 10 the remainder should be the last digit what is the last digit 3 so the remainder is 3 so r is 3 here here next statement s is equal to s plus okay s is equal to what is the initial s value 0 okay 0 plus Power of r comma 3. Okay, r power 3. Okay, power r comma 3, which is nothing but cube of remainder, which is nothing but, okay, what is the r value here? 3. 3 comma 3. So it is nothing but 3 cube. So which is nothing but 0 plus 3 power 3. How much? 27. So S value is 27. Initially S value is 0. Now S value is 27. Okay. So here if you see S value is 27 now. Next statement. N is equal to n by 10. It will give the coefficient. You see, if you divide, if you use this symbol backslash, it will return the coefficient. It will return the coefficient. So n is equal to 153 by 10. If you use percentage, it returns remainder. If you use backslash or division, it will return the coefficient. Okay. What is the coefficient here? 1, 5, 15. What is the n value now? 15. Okay. So what is n value? 15. Again it will check the condition. N greater than n. What is the n value here? 15. 15 greater than 0. Condition is true? Yes, it is true. So it execute these three steps. R is equal to n percentile 10, which is nothing but, okay, what is the n value now? 15. If you divide 15 by 10, then what is the remainder? 5. Okay, 10 1 the 10 and remainder is 5. Okay, like this. So remainder is here 5. Again, S is equal to S plus power of R comma 3. S is equal to, initially S value 0, but now what is the S value? 27. So it is nothing but 27 plus power of R. What is the R value here? 5. What is the R value? 5. 5 power 3. Okay, here it is a 27. 5 power 3. What is the 5 power 3? 5 5 the 25. 25 5 the 125. So we have to add 27 plus 125. How much? 152. How much it is? 152. So now S will become 152. You see, S is 152. Initially it is 0, next 27, now it is 152. Okay. Next, it will check the next statement. N is equal to n by 10. What is n here? 15. 15 divided by 10. If you divide 15 by 10, okay, it will give the coefficient 1. 10 1 the 10. This will give quotient and this will give the remainder. So n is equal to 1 now. N is equal to 1. Again it will check the condition, n greater than 0. So 1 greater than 0. The condition is true. Okay. So it executes these three steps. R is equal to n by 10. 1. It will give the remainder, not the quotient. So what is the remainder? 1. What is the remainder? 1. If you divide any number, any single digit by 10, it will give the same digit. Okay. If you divide 1 by 10, the remainder is 1. Okay. Then we will execute the second one. S plus power. Here what is the S value here? 152. So it is nothing but 152. Power of R. What is the R value? 1. It is nothing but 1. S value is 152 plus 1 power 3 or 1 cube. 1 into 1 into 1. Same. 1 only. 152 plus 1, how much? 153. So now S value is 153. Okay, n by 10, n by 10. What is the n value here? 1. What is the n value? 1. 1 by 10. If you divide any single digit by 10, the quotient is 0. Right? 10 into 0, 0. Then we will get the remainder. Because these are the integers, not the floating values. If you declare as a floating value, then we will get the 0.1 like that. Okay. So n value is 0. Here what is the n value? 0. We'll check 0 greater than 0. Condition is false. The condition is false. Okay. Now it will check the initial n value. The initial n value is stored in somewhere, in some other variable, and the sum. If these both are equal, then it is a Armstrong number. Okay. Now you see here, in C language we use percentile to get the remainder, but in Oracle we have to use mod. We have to use mod. Both are same. Okay. First initial n value, next sum is 0 starting, next condition, next mod, next s plus power, next n by 10 and loop. Okay. You see, this is the program. I need 4 variables. Why? Because first is the number which I want to enter. Next one is sum, total. Next remainder. Next temporary value. Why? Because the initial n value I want to store in t. The initial n value I want to store in t. Why? Because see here, if you don't store this initial n value, anyway the n values become 0 after loop, after execution. You see, every time it will be 153, next 15, next 1, next 0. Okay, so n value changes for every loop. So first we have to store or copy this value, the initial n value, into some other variable. Then we can compare that variable to s. If both are equal, then it is a Armstrong number. Okay, that's why I need one more variable, store initial n value. Why? Because at the end, in all the programs for all the numbers, the n value will become 0 only. Okay, so I need one n value we have to enter at the runtime, and to add, which is nothing but sum. We need remainder every time, and we have to store initial n value in t. This is nothing but at runtime we are giving. Okay, the n value we are giving at runtime. Next, the initial n value stores in t. The initial n value, which is like 153. So t is equal to now 153. Again we have loop, n greater than 0, do the remainder, add the sum, and here truncate. You see, we are using truncate. Truncate means it will give only the coefficient value. Okay, for example, if you divide 153 by 10, the coefficient is 15.3, right? The quotient is 15.3, but I want only 15 for my next loop. Okay, so that's why I'm using trunc. Trunc means it remove all the decimal values. Trunc means it remove all the decimal values, so it will give only 15. Okay, because whenever we divide by 10, it will give in the decimal values. Okay, so I'm using trunc, so it will give only the exact integer number. Okay, so this will become next n. So this is about the logic here. After that, okay, we have to compare the initial t, which is nothing but initial value of n, and sum, which we calculate. If both are equal, if s is equal to t, then we can say the given number is Armstrong number. Here I am mentioning T. Why? Because at the end n value is 0. For all the numbers, whenever you use, at the end n value will become 0. That's why I am using T. T means temporary. Else T is not Armstrong number. Okay. These all the programming languages problems. Okay. We have in our C language, right? That's why if you learn C language, all the languages will be easy for you. The first step we have to do, we have to open server output, which is nothing but on. Next, enter the value of n, 153. Okay, here we should not use ఇక్కడ కదా. Otherwise remove this. Okay. Okay, this one is correct. You see, the given number is Armstrong number. Here we got error. Why? Because it should be equal to 0. The initial s value should be equal to 0. So I initialize here only. Okay. Or else you can use here also. Here also you can initialize. We can have both the ways. You can initialize here or you can initialize here. No problem. Okay. Both are same. Okay. And we have some other numbers. 370. 370. It is also Armstrong number. Next one, 371. It is also Armstrong number. Okay, 371 is also Armstrong number. For example, tell me any other number. 127. It is not an Armstrong number. Okay, na? That is the thing. This is the assignment. Write a program to display reverse number. For example, if I give 697, it will display 796. 796. It is the logic here. Initially, S value is again 0, while n greater than 0. While 697 greater than 0, it is a remainder. Okay, remainder. For example, here I will explain the logic. Here, what is the n value? 697. 697. It is greater than 0, right? Next to remainder. R. Remainder. It is nothing but percentile. It is related to C language algorithm. Okay, but we cannot use this percentile in Oracle. Okay, in Oracle we should use mod. We should use mod. Here we should use truncate. Here we should use truncate. Okay, see here we should use truncate here. In C language no need to use truncate and no need to use mod. Okay, the logic is, I will explain the logic. Okay, 697. This percentile we can use in C language, not in the Oracle language. Okay, to get the remainder, we should use mod function in Oracle, and the get the quotient we should use truncate. Okay, 697. So what will be the remainder? 7. Here, S value. S into 10. What is the initial S value? 0. 0 into 10. Okay, 0 into 10 plus R. What is R? 7. Okay, so S is equal to 0 into 10, 0. 0 plus 7, 7. So initial value of S is 0. Now it will become 7. Okay, now S will become 7. S will become 7. And next is N by 10. In C language, it will give the quotient. Okay, so we also assume that it will give the quotient 697 by 10. So what will be the quotient? It is nothing but 69. Which is nothing but 69. So now n value is 69. Okay, next it will come loop and it will check the condition n. What is the n value now? 69. What is the n value? 69. Okay, R is equal to 69 percentile 10. So R is nothing but remainder. It will give the last digit, which is nothing but 9. Again, S is equal to S into 10. What is the S value now? 7. What is the S value? 7. So 7 into 10. 7 into 10 plus R. Now what is the R value? 9. So which is nothing but 9. So S is equal to 7 into 10, which is nothing but 70 plus 9. 79. 79. So what is the S value now? 79. What is the S value? 79. Next, N is equal to N by 10. What is the N value here? 69. 69 divided by 10. When we are using this symbol backslash, it will give the quotient. Okay, N is equal to 6. So what is the N value? 6. S value 79. R value 9. Okay, so remove this. Here also. Here N is equal to 6 now. N is equal to 6. N is equal to 6. Again, R is equal to N by N percentile 10, which is nothing but 6 percentile 10. So R is equal to, what will be the remainder? 6. If you divide any single digit by 10, the remainder is same. Okay. Next, S is equal to S into 10 plus R. What is the S value now? 79. What is the S value? 79 into 10 plus R. What is the R here? 6. What is the R? 6. S is equal to 79 into 10. How much? 790 plus. Okay. 796. So what is the S value now? S value is now 796. N. N is equal to N by 10. What is the N value? 6. 6 divided by 10. So what is the N value now? 0. When you divide any single digit by 10, the quotient is 0. The quotient is 0. So n is equal to 0. 0 greater than 0. Condition is false. Condition is false. So when the condition is false, it come out from that loop. Okay. Now it will compare the initial n value. We store in initial n value, or we can simply display this one s value 796. Okay. This is the logic behind the reverse. In C language, we are using percentile. Here we are using mod. Okay. And in C language, simply you divide by 10. But here we should use truncate. Okay. It is a program to display reverse number. Okay. Enter the value. For example, 384. It will return 483. 483. For example, 2808. It will return 8082. For example, today is a 1908. 19 August. It will return 80 is 91. Okay. So this is about reverse. Reverse of a number. This program to display sum of digits. Same logic. It is nothing but same logic. Initially s is 0. If you divide, you will get the remainder, and here you get the quotient, everything. But it is a C logic, C algorithm. Okay. But in Oracle we have some different. Okay. Okay. Na? This is count of digits. This is count of digits. The same logic. Okay. Do practice. This is sum of digits. Sum of digits. And this one is the count of digits. Okay. Both are different. Sum of digits and count of digits. Okay. Just in the interview, if you ask the basic, then just got the only the logic behind that. What the logic behind Armstrong number? S plus power of r comma 3. Remaining all are same. N value both are same. Only this is different. Reverse number. Multiply with 10 plus r. Sum of digit. Every time you have to add remainder only. Every time you have to add remainder only. Count. Every time you have to add 1. Every time you have to add 1. Okay. This is just logic. Just remember this thing. Remaining all are same. For Armstrong number, reverse number, sum of digits, count of digits, for all it's the same. Okay. Only here the one line, one statement. For Armstrong, we have to make it is a cube power. Reverse number multiply with 10. Sum of digit just add remainder. Count of digits just add 1. Okay. At a PLSQL program to select EMP details from EMP table. Yesterday I explained you, right? Percentage row type. Percentage row type means it will declare the one variable even for all the columns. For all the columns. How can we retrieve? Just variable name dot column name. Variable name dot column name. Variable name dot column name. Okay. For example, if you have 40 columns, no need to mention 40 variables. Just create one variable for row type. Okay. And just use that variable and use the column name. Okay. Variable name dot column name. You will get all the information. Okay. Na? So this is about 19th session. Okay. For example, instead of here, employee name. Employee name. employee name. Okay, employee name what? पानी जा रहा अलमान. Okay, employee name what? Employee number, salary, department, and manager. Okay, na? Thing. Okay, it is this information. This is the end of the. Actually, it is the 19th session. If I take, actually, I'm used to take 2 hours. Okay, and then it is my 19th class. Actually, I used to complete in 25 sessions or mostly 30 days if I'm taking 2 hours. Okay, but I don't know what happened to our batch. Okay, sorry guys for that. It takes 4 months due to some. Okay, tomorrow I will explain cursors and we have exceptions. Okay, this one. And on Sunday I will take a long run program for maybe 3 hours. Okay, you are available right on Sunday, Ishwar and Anil?
Yeah.
Okay, okay. So Sunday I will take like some tomorrow also. Tomorrow also. If you okay, tomorrow also I will take. And we have some time, right?
Yeah, okay, sir, tomorrow.
Tomorrow
Yeah,
seven
tomorrow
to
week off now.
nine. 7 to 9. Ishwar ji, okay?
Okay,
Actually, okay. Tomorrow 7 to 9. Morning 7 to 9.
okay,
Uh, and Sunday also. Okay.
okay.
Okay. Okay. Okay. Okay. Okay. Thank you. Ishwar ji, any doubts? These new topics, cursors. I will explain tomorrow. It's just a okay, na? I will explain this one tomorrow. Cursors. Tomorrow we will complete cursors, procedures, and exceptions. And Sunday I will explain these two, these four trigger sessions and
Okay,
everything. Okay. Okay. Thank you. Thank you,
okay.
Ishwar. Thank you, Anil.
Thank you, sir.